Okay, now we're going to finish up the notes for chapter 2. And believe it or not, after this chapter, we're going to have our first chapter test. So it's going to be over chapters 1 and 2. Okay, so now we're going to talk about chemical formulas. And chemical formulas are very important in chemistry because it tells you what you have in your compound and it makes it really easy to write out things. It's kind of chemistry shorthand. So what I have here is a couple of what they call diatomic elements. Hydrogen, when it's by itself, there's always two together, so it's H2. Oxygen, here we got water, and then hydrogen peroxide. You can see the difference between the two. H2O2 is hydrogen peroxide, H2O is water. These are two different compounds even though they're made out of the same stuff. Carbon monoxide, carbon dioxide, methane, this is an organic compound, and ethylene, these are organic compounds. But again, C2, here's your 2, and then 4. So you always have everything representative, and there's different ways of naming them depending on what type of compound they are, and that's what I'm going to tell you about today, or that's what we're going to go through. These are molecular compounds. In other words, they form molecules, okay? And usually these are going to be two nonmetals. When you put two nonmetals together, you're going to get what they call a molecular compound, and that's what all of these on the side are, okay? When I say diatomic, it means when they're pure, when they're by themselves, there's always two of them. There's only 7 elements that do this. But you will never find hydrogen as just H. It's always H2. The same with nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And I think there's a periodic table in your book that shows you that. But these 7 elements, when they're pure, when they're by themselves, it doesn't mean when they're combined with something, there's 2 of them. But when they're by themselves, there's always 2. And later on when we start writing up reactions, it's really important that you remember that. Okay. So we have several ions, and what an ion is it's an atom that gave up electrons or picked up electrons. So now it's not neutral anymore. It's short electrons, so it would be positive, or it gained electrons, so it would be negative. And the non-metals over here, these are the ones that pick them up. And it depends on, see, these guys only pick up 1. That's why they're negative. These guys pick up 2. That's why they're 2 negative or negative 2, whichever you want. Nitrogen 3. So these are the common ones. You see the noble gases don't have any charges, and the reason for that is they don't combine with anything. The noble gases are very stuck up. They just hang by themselves, don't like to join any other group, just stay alone. And over here, the metals are the ones that give up their electrons. Okay, so they're all positive. These guys are all 1, these guys are all 2. And I'll have a chart in there that if you run that off, it's really good. It helps on naming these all these compounds. But when an atom of a group loses, it loses electrons, it becomes an ion. If they gain, it becomes. Now there's 2 different names. If they lose electrons and become positive, they call them a cation. Okay, and I always remember that because when I had cats, I was positive when I got home they were in trouble. So if you're positive, the cat is in trouble, positive is the cation. Yeah, you can remember it any way you want, but that's how I did, because I remember my cats and they were always in trouble. I was positive they did something wrong, so that's why I knew the cation is positive. Okay, and then the anion is just the opposite. This is going to be the one that gains electrons, the one that becomes negative. Okay, and these are the nonmetals. And again, so you have cations and you have anions. Cations become positive, I should say. And anions, they gain electrons because they gain negative charges that become negative. Okay, here's some common ones, and I won't spend a lot of time on these because, like I said, that chart, if you look in the discussion or the page for this, you'll see I have one of these, and if you run it off, it's great because it's really good at helping you name these compounds. Okay, and here's the anions. Again, these are all on that chart, so you can look them up. Okay, so when you write formulas, you have to write the symbols and you have to make sure you write the charge, because when you have a compound, the overall charge has to be 0. Okay, so if the charge isn't 0, you got to fix it. You got to add some subscripts to make it 0. Now I'm doing magnesium and nitrogen here. Magnesium has a charge of +2, nitrogen has a charge of -3. If they equaled each other, I wouldn't have to do anything. I'd just write Mgn. But they don't. So what I do is I crisscross them. I put the 2 from the magnesium here and the 3 from the nitrogen here. Now if you looked, 2 times 3 would be +6, and 3 times 2 would be -6. So they would equal each other. So the formula for magnesium and nitrogen together is magnesium Mg3N2. We call this magnesium nitride. What you do with the second one is you change the ending to IDE. And again, that's on that chart that I gave you. Okay, because compounds are electrically neutral, you can determine the formula. And this is what I did. Write their charges. And then if they equal each other, you don't have to do anything. But if they don't, you need, I say, to crisscross them. Here that says you can divide by the whole number ratio and greatest common, whatever. Just crisscross them. That makes it really simple. Okay, so here we have examples. Write the empirical formula for a compound if we took aluminum with 3 and chlorine with 1. Okay, so all I'd have to do is put Al, it has a 3, and chlorine has a 1, so it'd be AlCl3. I just crisscrossed. You don't have to write a 1, you guys. Okay, here aluminum and oxygen, so I'd write Al and I'd put the 3 by oxygen and I'd put the 2 by aluminum, so it'd be Al2O3. And here we have magnesium, and NO3 is what they call a polyatomic ion. And again, those are listed in that chart that I gave you. You put that is a unit. It is a molecule with a charge. So they call them polyatomic ions. But again, it has a -1 charge and this has a 2. So I'd go Mg and then I put this in parentheses and I put a 2 by it. Okay. For the following ionic compounds, now we're doing sulfur. And again, you can see because this one has a charge of 2, so does this one. If this one has a charge of 3, you just crisscross them, okay? And again, sodium is +1. Phosphate is a polyatomic ion, PO4. That sticks together, but it has a -3 charge. So I'm going to put a 3 by the sodium, okay? So that's how you do when you're naming compounds, okay? When you do inorganic would be when you have metals and you have more than 1 charges. And you can see this on that table I gave you. If you have an element that has a split box, like iron, it'll say Fe+2, Fe+3. That means they have more than 1 oxidation. And it's important that you tell me which one it is because iron 2 oxide and iron 3 oxide are different substances with different properties. So when you have more than 1, you have to tell me which one it is by using a Roman numeral. And again, I'll show you that in a minute. And then again, when the second word, the negative one, you always change the ending to IDE. So if it's nitrogen, it's nitride. If it's oxygen, it's oxide. If it's sulfur, it's sulfide. You change the ending. If it's a polyatomic ion, and those are listed in that chart in the middle, don't mess with their name. Just write the name as it is. Leave it alone. Okay? There are patterns that you'll see, like you'll see NO2 and you'll see NO3. If this is nitrite and this is nitrate. You have SO3 and SO4, sulfite, sulfate. So it's important that you write the name right. You can't just write ATE for all of them. There's ITEs and there's ATEs. And then there's phosphate and phosphite. So you got to be careful when you're doing them. The one that has the more oxygen has ATE. The one that has the less is ITE. And again, this is just to remind you, look at the formulas carefully when you write them and make sure you write them properly. Okay? When you're naming binary molecular compounds, okay, what these are 2 nonmetals. All right? There's no charges. You don't have to crisscross. You don't have to do any of that. What you need to do is you need to make sure that you tell me how many of each you have. So what you do is you use these prefixes. All right? So the name of the element farther to the left of the periodic table. In other words, the one that's closest to the metals, the one listed first, or the one lower in the same group. That's the one that's listed first. Okay, and then the second one, you have to put the second one has to have a prefix no matter what. Okay, if there's only one of them, you use mono. Now the first one, if it only has one, you don't have to write mono. For instance, if I write CO, capital C, capital O. C is carbon, O is oxygen. Okay, I would write carbon, leave that name alone. And for the second one, I'd write monoxide. Okay, so the second one always has to have a prefix and you change the ending to IDE. Okay, so here's some again. CO, C is carbon, O is oxygen, but there's 2 of them, so it's carbon dioxide, 2 oxygen and oxide. This is oxygen, but I changed the ending to IDE. Again, on that chart that I have for you to run off, it already has these guys' endings changed to IDE. Okay, C, carbon, and now I have 4 chlorine. Tetra is the prefix for 4 chloride. Okay, right? If the prefix ends with an A or an O, you can leave out that. I tend to write it in there. It's not a big deal. But here, like I have 2 nitrogens, so that dinitrogen. Again, if there's only one listed first, you don't have to put a mono in front. But if there's 2, you have to tell me how many there are. So dinitrogen, and then there's 5. So pentaoxide. I guess I'd say penta just because that's the way it's up to you if you want to leave it on or leave it off. It's not a big deal. Okay, so naming this one, S is sulfur, and then 2 oxygen, sulfur dioxide. Okay, here we got phosphorus and 5 pentachloride. Here we got 2 chlorine, so it'd be, and again, on your chart, it's going to say chloride. But if it's the one listed first, you leave the name alone, so it'd be chlorine. So it'd be dichlorine, and then 3 oxygen trioxide. Okay, so you got to be careful with that chart, because if you see P on there, that's phosphorus. But on the chart that I gave you, it says phosphide. It's already changed the ending to IDE because that's the most common way for it to work. But if you're doing it, if it's the first one listed, you got to make sure you write the name as it normally is and not change the ending to IDE. That only occurs on the second one. Okay, and here's your chart over here. I would write this down on your periodic table. Okay, so again, C, carbon disulfide, carbon monoxide. That second one has to have mono. This would be tricarbon dioxide. This would be carbon tetrabromide, and this would be carbon mono because it's only one, fluoride. So the second one has to have a prefix. So you got to remember that. Okay. If you're doing the formulas, same kind of deal. Silicon is Si, and there's no more. It's just one, so Si, and then tetrabromide. Bromide is Br, and there's 4, so it'd be SiBr4. Disulfur, S2, dichloride, Cl2. Diphosphorus, P2 hexaoxide, that would be O6. Okay, so that's the naming, and I'll have another couple videos for you to watch because that was kind of quick, but it's really important that you understand how to name these compounds, because we are going to do this now every chapter from now on, and I need you to know how to name compounds. We can't go back and review this all the time. It's something you need to do. So again, there's some information extra after this to help you with the naming parts. If you're struggling, make sure you go through them. And this is the end of chapter 2.